All right. Can everyone hear fine? Yeah? Cool. Okay, so let's get started. My name is Frank. I do a bunch of things. I'm a consultant freelancer. I pretend that I write a blog at ioscoachfrank.com. And today I want to talk about NSOperations because of this talk. WWDC 2015 Advanced NSOperations. Who here has seen this presentation? So, okay, maybe like 20% of the room. When I saw this talk, I was floored. I thought this was like the coolest thing in the world. And you'll see. So today, I'm not going to like drown you with code. The idea is more to kind of get you excited about NSOperations. About as excited as anyone can be for NSOperations, you know. We're not going to be like, oh, NSOperations, yeah. But try and get you excited about NSOperations. We're going to talk about what they are, what they are in theory, and then what they look like in the real world. And then we're going to look at a whole new world of NSOperations, which I'm excited to get into. All right, so let's start. What's an NSOperation? The floor. What's an NSOperation? Does anyone have any good answers? The thread, contain tasks. A unit of work. That's probably the best. That's probably the best way to think about NSOperations. A unit of work. Nice. When I started thinking about NSOperations, to me it was like a wrapper around a block of code. And by the way, when I talk about NSOperation, it also means like in Swift, it's operation. I'll be using both interchangeably, so you know they're the same thing. So it's a wrapper around a block of code. Luckily for us, Apple supplies a class called block operation, which essentially is an operation that wraps a block of code. So, for example, you can create a block operation called hello world op that prints hello world, and then call start, and then boom, it prints hello world. Wow, crazy stuff. All right, thanks for your time. We're done. So that's not interesting in and of itself, right? Now what starts to get cool is that they're run by something called an operation queue. So instead of running these things yourself, you can hand them off and kind of like delegate their running to something else. And it looks a little bit like this, where you create an operation queue. Here we're creating the same hello world operation, and we call operation queue.addOperation, and lo and behold, it's going to run. Awesome. But again, still not that interesting. You can actually do this with dispatch queues, so we're not quite at the cool stuff yet. What makes NSOperation really powerful is that it comes with a bunch of really, really useful features. For example, they're cancelable. So if at any point you create an operation that's doing some work and you decide, I don't want to do that work anymore, you just call cancel. If you have a plain nickelback operation and then you want to end that, well then boom, you can do it like that. You can also create dependencies between operations. So you can be very strict about the order in which operations execute. So say in this example, if you wanted operation A to run before operation B, and then operation B to run before operation C, you just do this. You add operation A as a dependency to operation B, and then you add operation B as a dependency to operation C, and you're good to go. This is some guarantees that they won't run at the same time. What's nice too is that they're multi-core aware. So NSOperation queue, I guess in its default setting, will run as many operations on as many cores as it can. It's a really, really simple way, well not simple, it's a very easy way to unlock performance in like long-running tasks or tasks that can be done concurrently. And finally, I think this is kind of the coolest thing about NSOperations, that they really like encourage a black box approach where you have stuff that comes in and stuff that comes out, which makes them easy to test. And it kind of encourages good development practices like single responsibility principle. But now, so that's a theory. They're little units of work. You can think of them as like blocks of code that run and that have all these extra features. You can cancel them, you can add dependencies, you can do all this stuff. But what do they look like in the real world? Essentially, there are three, at least in the things that I do, there are three main kinds of operations. You have synchronous operations. Operations that do synchronous work. You call start, they do their work, and then they're done. This can be something like parsing JSON into a model object, checking for location permissions, or saving to NS user defaults, if you wanted to put that in an operation. Essentially, it can be as simple as this, where you subclass the operation class, and then you override its main method. If you're a good citizen, you check to see if it's canceled, because there can be some race condition stuff that happens. But aside from that, you just run whatever code you want to run right inside that main method, and there you go. Now this is where things get a little more interesting. The next type of operations that you find in the wild are asynchronous operations. So these are operations that you run, and then they stay in the queue for for a good amount of time until something else tells them that they're finished. This can be, I mean, obviously network requests come to mind, but things like connecting to a Bluetooth device is something really interesting that you can model with an NS operation. Same thing for like CloudKit operations as well. All of the classes that operate on CloudKit are all actually operations under the hood. So what does that look like? Ooh, okay, now this is a little more code. You have to do some subclassing to get like asynchrony to work in a way that makes sense. But essentially, you override a few variables, and then you add this function that's called complete operation, so that you can actually, from your code, tell the rest of the system that, okay, this operation is complete, and then it raises the right flags, and then things continue. So that's the second kind of operation that we have. And then the third is UI operations. So say if we have operations that want to show UI, like showing a UI alert controller, or even showing complete flows of UI, like you could, for example, wrap your onboarding, your login process into an NS operation, and kind of give it that kind of data in, data out model. And this is the same as an asynchronous operation, so like you just have to dispatch it to the main thread, and you're good to go. So, with that being said, let's look at a whole new world of operations. Whole new world. A new fantastic point of view. What these little units of code allow you to do is create like blocks that are composable and reusable, and this is really, really powerful. If you, especially if you're a freelancer, if you're a freelancer and you want to reuse more code from project to project, this is a great way to go about it. So these are small blocks that can be composed and reused, and because they share the same interface, it becomes really, really easy to build components that run with operations. So how are they composable? Oh, and essentially, if you can draw a flowchart, you can use NSOperations, and we'll see how. So some quick examples. So say, okay, so we're going to look at downloading and parsing, activating geofence push notifications. So this is cool. And the last one will be parsing large data sets. So downloading and parsing. So this is something we all do, right? Download data, now we have to parse it, and then we pass on that data to the rest of the system. Pretty much every app does it, and it's the same code over and over with minor differences. This is a great candidate in and of itself for abstracting in an NS operation because it's a small unit of work that you want to have run like asynchronous and concurrently to the rest of your code. And pretty much the more you can do on like separate threads, the better. However, this is actually, I guess, two different you have like two different units of work here. You have one unit that's downloading and you have one unit that's parsing. So this is another way that we can take like downloading and parsing and then break it down even further. What's interesting here is that both of these blocks in this diagram, downloading and parsing, are useful on their own. So you can have a download operation that downloads, for example, images and saves them to disk. Or you could have a parse operation that parses like a JSON file that's on disk and then loads it for like your testing suite, for example. These are both useful in and of themselves. And they also support, they also like cleanly support data in, data out, where you give your download operation a request and it spits out NS data, and then your parse operation, you grab that NS data, deserialize it, and spit out objects. But then you're going to do this all the time, so then you can take those two parts and then wrap them once again in something that abstracts them both away, which I like to call an API operation. I have examples of something like this on my blog, and there'll be a link at the end of the talk with this. So again, we take our operation, we break it down into parts, but since we often use both of these parts together, we can wrap them in a bigger operation and then just reuse that one block instead of always having to create two operations every time we want to download and parse something from the network. So that was cool. That's how we can take these things and make them composable and reusable. Let's look at another example. This is something that happened to me in a recent project where we wanted to activate push notifications that were triggered by a geofence. So that means that when the user does an action that would like tell us, okay, now we need to create a geofence. First, we need to ask for location permissions because we need that to know where the user is. Then we would ask for push notifications because we need to alert the user. And then finally, if all of these things work out, then we can go ahead and create the geofence around the user. So the idea was that you would say like, oh, I like this restaurant, I want to remember, say for example, to use a coupon when I'm near. But then it's like, okay, can we have your location? Can we send you push notifications? And if all that's true, then create the geofence. What's really interesting with this kind of model is that you have very clear seams where you can do your error handling. So between each operation, you have a good spot where you can check like, okay, did this succeed? And if it failed, why did it fail? For companies that are very analytics driven, managers love this.
Shoot. You keep showing this global, like you have an input and then like after operation finishes, you get like output like objects, for example. How do you actually get those objects? Because like you override the main function because there's nothing. How do you get like the objects from the operation?
Yeah.
When it's done.
That's a really good question. I mean, the best way, like the best answer I can give you is with an NS operation. But really, yeah, it's something that you can do where when you create an operation, you can create a block that handles passing data from one to the other. And then using the dependency model, you can go ahead and say, okay, when say for example, priming for access finishes, then you would have like say an enum that would give you you would have like a result enum first of all to say if it was successful or if it was canceled.
Basically, you have to like create it on your own. There is no like built-in way to do that. You have to pass it in your code, right?
There could be a built-in way.
Okay.
There could be a built-in way in that. I mean, all of this stuff is Apple is like it's essentially an Apple template class. So you can go ahead and add whatever you want.
Yeah.
If you check out the talk for advanced NS operations, the sample code is absolutely incredible. But it's Swift 2, I think, so good luck compiling. But what they do in there is that they end up subclassing NS operation Q in order to add functionality to NS operations where you can say, okay, when one finishes, take like essentially like if it implements this delegate method, take the data returned from there and then give it to the next one. So that's one option that you have. I like to stay away from that kind of stuff and keep things like as close to like the Apple basic. So I usually end up having like little block operations to pass data from one to the other and also handle errors. And that way it becomes very explicit to see like how the errors are handled when they're serviced. So again, you have very clear schemes to handle errors. I'm parsing large data sets. Now this is a little crazy. I don't expect you to read any of those little boxes. But essentially, like I mentioned earlier, I'm working on a Magic the Gathering app. So who here doesn't know what Magic the Gathering is? Okay, well, it's a card game that's been around for like 25 or 30 years. It's been around for a really long time. There's like tons of cards. The data sets that I use in my app are like, there's little, between those first two blocks of downloading expansions and the cards, there's maybe like 50 to 100 megabytes of JSON in there. So like, it's a lot of data. It's enough where if I just try and like straight up parse it, it'll take it takes a long time. I tried it. I remember testing it on like an iPhone 5, and I was waiting a few hours, and I'm like, okay, this isn't going to work. So this is kind of a simplified example, but what I end up doing is I download both data sets, and then I break them up into separate operations that I then run in on as many cores as I can. So if I'm on a Mac, for example, like can you imagine like an iMac Pro with like 18 cores? Like, it would blaze through it. But yeah, so I chunk these up into separate operations, and all of this needs to be fed to core data as well. So I chunk it up and then save it to my and its managed object context, and then once both branches have completed, then I do cross-referencing between them, and then once that's done, then I push the whole thing to the background context, so it can save it to core data, and then I reload the UI, and everything's nice and fancy. I don't know how I would have done something like this without NS operations, and yeah, this is, sometimes I amaze myself. I have to sometimes look at the code like 6 months after I wrote it, and like I go in and I'm like, hey, I still understand all of this stuff, you know, it's incredible. Like, if I hadn't done it that way, it would have been like blocks within blocks, and it just would have been a mess. So it's good for that too. I hope this has kind of gotten you excited at the possibilities of the things that you can build with NSOperations. Oh, another good example while I'm at it. I have, for example, I have a data source that's driven by an NS operation. So essentially, I pass it like this API operation that again is driven by, say, for example, like a request and a model object output. So create a data source, feed it an operation. That operation is then with a request, and then suddenly, boom, easy peasy. You have a table view running with data that's parsed from the network. So it's great. It works out like it speeds up your development, and since you're reusing components, it becomes very easy to test because all of this stuff comes from the same code. Makes it difficult. Debugging can be a bit of a pain, but there are good tricks on that too. So that's pretty much all I had to say. There are resources. If you go to bit.ly/Tacow 2017, that's a link to a bunch of articles and resources that I have on my blog. You can check it out. It tries to stick to the Apple source material as much as possible and keep things really, really simple. So I hope you'll give it a try and check it out. And if you ever want to reach me, I'm at Frankacy on Twitter. So if you ever end up using NSOperations, I'd love to hear about it. So thanks a lot. Any questions? Sure.
Yeah, sort of mentioned it. It's weird how Apple doesn't give you asynchronous operations out of the box. They don't give you, they just give you the basic stuff. Every time I want to use operations, I look for a project, hacky things or managed where Apple source code. So is there a project that you would say is like the definitive, NSOperation kind of thing?
Definitely. There's two I find really important projects, one in Objective-C and one in Swift. The Objective-C one is called the NSOperations kit, and essentially it's an Objective-C port of the Swift 2 code from the advanced operations talk. So there's that, although it hasn't, I don't think it's been updated in the past few months. So, but it'll still compile. Oh yeah, it'll compile. But I mean, this is code that I've used in client projects before, so like I can attest to the fact that it's rock solid and it works as advertised. There's also a more updated version of the Swift, of the advanced NSOperations code, and that's actually kept up to date, called Procedure Kit, and that's another thing you can check out. And that's really more of a Swift update to the old code that was presented by Dave.
When it comes to network operations, most of the examples that I've come across involve grand simple dispatch. Under what circumstances do you recommend using operations over GCD?
I recommend using operations. That's an excellent question. So why would you use NSOperations over GCD, and in which circumstances? If you're in both, so in both cases you can accomplish pretty much the same things. So let's say, for example, that you have two network requests that you have to wait for to return, and then launch a third network request, and then once that returns, reload the UI. That's something that you can do with Grand Central Dispatch. In Objective-C, it's a bunch of C APIs, so it's up to you if you want to do that. But I feel like operations were really built for this kind of use case. Using dependencies, it becomes very explicit what you're trying to achieve. You're not using dispatch semaphores or whatever. There's no signal counting. It's all very clear.
You look at the documentation for GCD, they sort of list the hierarchy of different that you use.
didn't know that.
I think they are.
They're built on it, but the idea is that you should use the thing that's closest to the level of stuff you're working on.
Yeah. So yeah. Oh man, I'm not like up to date with what's going on with Procedure Kit, so I can't really comment on that. I think adding promises to adding like mixing promises with NSOperations makes a lot of sense. But again, it depends how it's implemented and stuff. But yeah, I don't really know exactly what they're doing, so I can't comment. But I mean, in theory, it sounds alright. Yes.
I like how in your API operation you had like your network operations and parse operations very modular and a bit testable. It should be pretty easy to test this stuff if you have to do that in other distribution.
Yeah, I do. Unit testing operations is actually really it's really nice because on the one hand, I mean you can test the stuff that's like your domain. So say for example, if you build a parse operation, you can test that parsing works as you expected. But then what's interesting is that you can have like a whole suite of tests for like, is your operation a good citizen? So there's a bunch of things that Apple expects you to do. Like say for example, if your operation is canceled before it starts, well then in its start method it should return and not run because you're overriding that method. And otherwise they would have stopped it. So if you have like when you have that like test suite set up, it becomes very easy to make sure that your operations are running correctly. Shoot.
In the beginning, like I already mentioned that you do some stuff with UI operation, right?
Yeah.
Can you force it to like operations to run on the main thread because like you use the UI
Yeah, absolutely. Yeah, all you have to do is dispatch async main queue, and you're good to go. You can also
so you would have to like wrap the UI code inside the dispatch queue inside an operation. Why not just use the
Well, you don't have to use GCD to put it back on the main queue. You can use NSOperation.
You can tell operation queue what queue to run on.
Yeah, you can. Okay, so you can also set up an operation queue and tell it which queue to run on. There's also the main operation queue is on the main thread. So you also have like a class variable that gives you the operation queue that's running on the main thread. So you can also enqueue it there. Although I find it's a lot safer if you wrap it in the dispatch group, like, just in case.
Not to bring this, but you would want to dispatch async from inside of the operation because that would return immediately and you would end the operation before you knew whether or not your stuff would actually continue.
Oh right, but then in that case you'd have to.
So you could dispatch sync it inside of the operation, right? And that way your operation doesn't complete until whatever it is you're doing on that UI is done. Because if you dispatch async in the operation, will return when it's finished state.
Yeah, no, absolutely. But also,
Yeah.
but it also works if you have one of those if you have an asynchronous operation built that's built for you to once your UI is done, then you call complete
Right.
back on your operation. So
Yeah, I guess what I was concerned about is the positive race condition between the operation claiming that it's done, but the actual work that it was asked to do was not done.
Right.
Right? Like because you've left the operation as soon as dispatch.
But again, like that depends. If you're subclassing NSOperation, you don't have to necessarily set the finish flag once execute is completed. So
Right.
so like say for an async operation, like say for a network operation, that's generally like the approach that I've taken is where you execute, you do your network request, your execute method returns, but your operation is still in the queue because it hasn't finished yet. So your queue doesn't see it as finished until your request returns, and then as it's going through its completion block, then
And then you can basically either fire a notification for you in UI code or whatever, and then there you would make sure you're on the main thread and then just
pretty much.
So your dispatch async then is what's setting the finish on the operation. So then you need to make sure that you are capturing a strong reference to that operation. You might get rid of it, or it'll hang on to it because it's got doesn't have finish set.
Yeah, it'll hang on to it. I think one of the most frustrating bugs actually is having something like this happen where you have an asynchronous operation and you forget to call complete in some code path. In Swift, it's not so bad now because you have defer, so it's really easy to say like defer completion, and then whenever you get to the end of the scope, you're sure that's going to be done.
Can you do that in the super class that you created? Where you create the complete operation function, you just defer it.
Probably wouldn't want it.
Actually,
Yeah, it becomes
If you do anything asynchronous inside there, you're losing yourself.
yeah.
You could wrap it in a try and throw it in and stick it in a file. I've never tried that. Please don't put that in production.
Yes.
Yeah, so the question probably have been asked, but I would like you to elaborate a bit more. How do you put together two operations?
Pardon me?
How do you put together two operations when one depends on another? In terms of passing data between them.
If you have a sec, I can just go ahead and do it this way.
A few years ago on the Apple developer forums, was it Quinn? I can't remember which Quinn it was.
Quinn the Eskimo.
Quinn the Eskimo. He did this post where basically he started to demonstrate the exact same things. And it was like this: someone turned on the light, and the developer used NSOperations. Like, oh shit, that's how we should be doing it. But basically, yeah, make your operations totally atomic with some sort of output property, and then have an operation that takes one in and perform some logic based on the result of that operation. Yeah.
Yeah, that post was good because I was actually wondering this as well. Like, how do you pass data from one operation to another without using Apple's crazy framework stuff? And it wasn't easy. Chaining series of NS operations.
Can you bump up the font size?
Yeah, sure. Enhance. So again, okay, so this is a really like dumbed down example. You can imagine something like this where download operation, parse operation, and then you create a block in between to say that that your parse operations data is equal to download operations data, and then you create the dependency chain, and then you add them all to a queue. So that's probably the easiest way. What's nice about this is like, again, this code becomes easy to abstract because if you're chaining an array, you can just like enumerate over it, create all the dependencies. So
In terms of error handling, when the first operation fails in this setup, will the queue execute the second operation and third operation?
Okay, so it won't do that by default. I have an article that talks about that. If you use a specific queue for, say, these operations, which you would if you were like grouping them together, like my API operation example. So if you're using a specific queue, then you can go ahead and say, this has failed, so cancel everything in the queue. So you cancel everything that's left, and then you don't have to worry about the rest. So instead of using one queue for all your operations, you end up using many queues, and they kind of know about each other behind the scenes in order to coordinate.
Awesome. Thank you very
Alright.
much, Brian.
Hey, my pleasure.